So why STEM? I've always had a passion for science. I've always loved the investigation from when I was actually in primary school, but also in high school in particular. And I enjoy the subject matter. But I do have other passions. I love art, I love food, like a lot of people. And in particular, I have the opportunity to enjoy these passions around the world. So when I was in senior school, I actually had particular science subjects that I did. I did maths, physics, biology, and chemistry. Now, maths and physics are very similar. It's a lot of working with numbers, but my passion was actually in the biology, understanding how both the human body and the animal body works. I had the opportunity to move from, I am Australian, from country Victoria to Melbourne and study at university. And I continued to study science there in university. And that's where I had my first exposure to doing science research and working within a laboratory. And I can't tell you how much I really enjoyed that. After doing the laboratory work, I actually finished a PhD or a doctorate in science. That meant that I was doing my own project. So you had a question to answer and you did your experiments to answer that question. But I didn't do it alone. I had obviously supervisors and other colleagues and other students who were also involved in those sort of studies. But after all the education part, where did I go in terms of my career? So once I'd finished my formal study, I did become a laboratory research scientist. I received money from government organisations to conduct experiments, again, in human medical research. I also had the opportunity to be, like your teacher, a teacher at the university level. And that was a great joy to me because that utilised my science communication skills that I had learned through my various senior and university years. After working in the university for about 10 years, I had the opportunity to actually join a scientific company, biotechnology company. So a lot of those companies make products that are used in research, in what they call life science research and medical science research. And all of these types of companies create with innovation and invent products. And so what I was involved with was help to invent new products, which our scientific and medical researchers could use to advance the work that they're doing. And in doing that, when you're trying to invent products, you need to use people like engineers who understand mathematics, who understand electronics, because all of the electronic equipment that you have at home or that you have in a laboratory requires engineers to design those. As I mentioned before, one of the great driving passions of mine is actually helping science, whether that be when I was doing science or whether I actually help other scientists and around the world to understand our products and improve their work and make their work a lot faster and to have their work reflect better science. And in a company, it's never static. It's never you make one product. It's always about, okay, what's the next product? What has technology done that allows us to make new and better products, either smaller or more accurate sort of products? And one of the other elements, as I mentioned before, being the CEO means I have to run a successful business. And that's not just selling products, that is also communicating and working with both my staff and customers all around the world. So one of the elements that I hope that you take on board is that I've had an opportunity not only to use my science communication skills, but also have opportunities to travel and meet people face to face. So what do we do as a company? Now, hopefully you don't get too distracted by all of the animation going on, but basically we make implants, which you can see here, that I'm hopefully that you can see my arrow working up in the top left-hand corner. And these implants can be inserted into an animal. You may have heard about humans having implants like pacemakers, very similar type of product. What these implants do is that they measure physiology. They measure things like blood pressure. They measure things like electrical activity in our bodies. And the technology that we use here at Kaha Sciences is both in the communication, but also in what's called wireless power. So you can see down here in this blue pad at the bottom here, there's these really thin lines. This is what we call wireless power. So this is so there are no cables, there are no plugs. So the device that's inside the animal is able to operate without any cables. So what we try to do is try to develop products which don't require any cabling. And that data is actually collected on the computer. And there's lots of data that's actually collected on the computer. So here's a picture and an animation, but what actually happens in real life? So here we have on the left-hand side, 2 rats, and inside of each of those rats is one of those implants. They're small enough to be inside the animals and it doesn't harm them in any way. And on the right-hand side, what you'll be able to see are these lines. So the red line at the top here is measuring blood pressure. So inside our bodies, we have a sensor, or inside the rat's bodies, we have a sensor, and you can see that the blood pressure goes up and down. Now, this is where your science background is very important in terms of understanding, well, what do these lines mean? So every single line there has a particular data point, and you can see the numbers on the left-hand side here. And as you're collecting this data here, it's actually being put into a table, and then you have to take those numbers and you have to analyze those. So in terms of the skills that I have obtained from doing science subjects, I have obviously the science and the maths is very important in terms of, as I mentioned in the previous slide, collecting the numbers, doing the statistics, looking at those numbers and seeing what they actually do mean in medicine in particular, but also in basic science. Lots of communication. So I've been very fortunate as I am communicating with you. This is the first time I have talked to school students, but I also do a lot of talking with engineers and scientists, and everything that we do and everything that I do is involves teamwork. So whether that is with my senior team here in the office, or whether it's actually the engineers who are developing our products, everything is done together. Nothing is done in isolation. Other skills is in the planning and organization, and I'm sure that your teachers have said that it's quite good to plan and organize when you're doing projects or when you're doing your homework. And problem solving. One of the things that I really do enjoy from my science background is all about, okay, I have a problem, how do I solve that? And you can actually be very creative. I mentioned that I like art. I do like to do my own art, but there's also creativity in designing products which customers can actually use, and making sure that engineers understand what design will allow the customers to use those. As I mentioned, there's a lot of opportunities. I've been very fortunate to, with all of my roles, to travel. So I've been able to travel internationally and talk to people in all countries, all continents, I should say, not all countries, all continents. And I also had an opportunity to live overseas for about 2 years, which I enjoyed immensely, because what that did was it actually allowed me to enjoy the culture and the people, both the science culture as well as the normal sort of personal culture, as well as providing a whole lot of new challenges. So able to learn new languages, But again, always coming back to the scientific investigation and the scientific core of my passion. One thing I wish, so I was asked this question as a slide, and one thing I wish I knew at your age before pursuing a STEM career, I think it was that there are people out there that you can talk to about how you can use your science background, and also talking to people that there are multiple careers related to science. It is definitely not a scientist sitting in the corner in a laboratory and doing experiments, that's for sure. So I've had an opportunity over the past 30 years to experience a whole lot of different both careers and opportunities. So now we've come to the end of the talk, and I'm open now for some questions, and I will leave that to your teacher to mediate those.
So, fire, Liz, are there some questions coming through? There we go.
I can see Liz is typing. Can the implant tell when a person is sick and what sickness? Yes, it can. Oh, well, when you say tell, what it can do is it can measure. In the case that I was displaying, it was measuring blood pressure. So I think many people are aware that in society there are people who have high blood pressure and have to take medication. You can also have a low blood pressure in the same sort of situation. So it can detect, but it doesn't actually report, oh, you have high blood pressure or you have low blood pressure. One of the things actually that it does actually draw on that I forgot to mention was this type of technology that we use in research laboratories is actually also being used to develop implants for human application, where again, it's looking to see you can monitor people's blood pressure. And so instead of having to always go to the doctor and visit them where they take a blood pressure recording, you may be able to actually have an implant which records the blood pressure, and this can go into the cloud or somewhere where you don't actually have to do a face-to-face with the doctor. So there's a lot of applications related to illness and detecting of illness. Good question. So how is the implant inserted into the rats? So we use exactly the same techniques in terms of surgery that you do in the human. And I'm experienced in doing all of those as well. So we make sure that we are very clean, just as in a human surgery. We wear masks, we wear gowns, we sterilize all of the equipment. And the implant is actually placed in the abdomen of the animal, so in the stomach area of the animal, because there's a bit of room. As I said, the implant is not very big, and the little sensor is actually placed inside a blood vessel. So that means that you are accurately measuring blood pressure. So as I said, the animals are anesthetized. They have exactly the same treatment as you would do in a human surgery, both before, after, and for many months after the surgery.
So,
other challenges. Okay, so how long have you been in this business, and what are the challenges of being a CEO? Big question, big question. With the Kaha Sciences, or with this actual company, it's been almost 3 years, but there's been different evolutions of the company. So within the area of scientific companies, I've been doing this for about 15 years. As CEO, this is my first CEO position, but I have had managerial positions previously. And some of the biggest challenges is obviously making sure that your staff are well looked after. And as I mentioned before, that our customers are actually getting the best out of our product. So making sure that the company stays in business, that's a big challenge, and especially with everything that is going on in the world today. We have a lot of our customers, like we've have had here in New Zealand, have had to work from home, and you can understand that not everybody has a laboratory in their house. It's not one of the rooms in a house. So there's a few challenges there, but what I do find is that that the role is not one that I do on my own. Thankfully, as I mentioned before, I have a team of good staff who are willing to help, and lots of scientists who are willing to provide feedback and suggestions for better products, and how our products can be used in different ways as well. Our products are, the question is, do you do all your testing and research on rats? We're a very fortunate company because a lot of the biotechnology or companies that make products are not able to test the products in animals. Usually they do actually have some customers, but we have a relationship with the University of Auckland, and one of my staff members works half-time at the university and half-time for the company, and we are permitted to actually test our products in the rats. So as I mentioned, our products are mainly used in rats, but they can be used in other animals like guinea pigs. And we do also have an even smaller product, which you can use in mice. So these are all common research animals. Okay, so what science achievement invention are you most proud of? I suppose one of the things, and I didn't get a chance to talk about it today, is that we just released a new product. So we have a relationship with some engineers here at the University of Auckland, and they have been using a technique where you can use light, and what this light can be used for is that it can actually be used on cells. So it can be used on cells to stimulate the cells. And they came and approached us and said, we have this technique. Are you able to make a implant that can actually be put into an animal, put into a rat, and that scientists can actually use for months, up to 6 months. And this area of research is a new area of research. It's called optogenetics. I know that you probably aren't aware of it, but basically it looks at the RNA, or the cell. I'll try and explain it as simply as possible. But basically what happens is that the light can actually target a single cell, and it can turn it on or turn it off. And so we were approached with this product last July, and we've been working for almost 12 months, and we released it last month. So that was I'm really proud of that achievement for our company and my staff. Whilst our research, our products are used, the question is, does your research include finding cures? Our product is actually used in a variety of different organizations. So I talked about scientists. Now, scientists are not only in universities, but they're also in pharmaceutical companies. And we do have some customers who work in the pharmaceutical companies who are developing particular cures for for medical conditions. I talked about the cardiovascular system, or the heart and blood vessels with high blood pressure, low blood pressure, looking at treatment of neurological disorders like epilepsy and Parkinson's disease. So whilst our products are not a cure, they are definitely used in looking at the development of either drugs or other ways of which you can actually cure these medical disorders.
Okay, I'm going to interrupt this session now because we've reached the extent of our allotted time, Joe, for the presentation. And via Liz, if your class have got some more wonderful questions, please feel free to send them through to the Wonder Project email address that you were given. So Joe, I would just like to take this time to say thank you very much for taking the time to give this Wonder Project STEM career presentation to Stanhope School. And I would like to say to Stanhope School and Fire Liz, thank you very much for coming along to our Wonder Project Zoom talk today. Thank you very much.